This video is going to explain to you how to calculate problems involving Boyle's law, and it's going to do so in a way that utilizes the relationships between the variables rather than memorizing an equation. So the variables for Boyle's law, the ones that are changing, are P, pressure, and volume, V. And our constants are going to be the temperature and the amount of gas in moles, or N. Now, there is an equation that states P times V is equal to some constant K. But the relationship is what we call an inverse relationship. We're going to say that if P increases, then V must decrease. And the opposite would be true as well. If P were to decrease, then V would have to increase. And a lot of times I'll use this kind of a shorthand. P going up means V has to go down, or vice versa. This is called an inverse relationship in math. Now, instead of using formulas to try to solve these problems, I think it's helpful to study the relationships. If you look at the example problem given, it says a sample of gas has a volume of 460 milliliters when measured at 35 degrees Celsius and 740 millimeters of mercury. Now, in that first sentence, you have here a volume, a temperature, and a pressure. And then you read the second sentence. It says, what volume will the gas occupy at the same temperature and 175 millimeters of mercury? So if you look at what you've underlined in terms of your variables, the only ones that are changing are the pressure and the volume. So I make a chart, and I keep track of what they are in each condition. So in the first set of conditions, I have a volume of 460 milliliters when that pressure is 740 millimeters of mercury. And then the question says, what will the new volume be when you change the pressure to 175? So this is how I organize my information. And I look at it, and I look at what's happening. The pressure is going from 740 down to 175. So pressure is decreasing. If I look at my relationship, if the pressure were to go down, that means the volume would have to go up. So what I'm going to do is I'm going to take my volume number here, the 460, and I'm going to multiply it by a fraction. Now, the fraction that I can create is either 740 over 175, and I'll write this right here, 740 over 175, or I could have 175 over 740. But I want the volume to go up because that's what the pressure is causing it to do. The decrease in pressure is going to cause an increase in volume. So only a fraction that will work is the one where the big number is on the top. So I'm going to put 740 millimeters of mercury over the 175. And if I do my math, and I do it carefully, and I pay attention to sig digs, I should get a volume of 1,945 milliliters. Now, if sig digs are an issue, which we should pay attention to them, I can only keep 3. So I would change that to 1.95 times 10 to the third milliliters. Now, what I would have you do is try your practice problem that's listed here down below. One of the things to be aware of is that you always have to make sure that your pressure units that you're using match. You can't do a problem if the pressure units aren't the same. Same with your volume. So in your practice problem, which is your learning check, you're going to see that the units match. You should be fine. Give it a try. And if you have questions, bring them to class the next day.